What's the big tell on A right here? What's the thing that makes you feel good about the W substitution? The difference in power is 1, right? So we think, Chris, what do you think W should be?
X squared.
Yeah, so what's dW?
dW is
2x dx, right? So what does dx equal? Over 2x, right? We good with that? So I've isolated now. What's the next step? One word. What's it called? What do I do next? No, I have to substitute. So this is really important, everybody. Watch this. Tell me what I am leaving out here. What did I leave out? The what are they called? The limits of integration. This is super important because this is the most common place, the easiest place to mess up on these. Here's the thing. What variable is this integral in terms of? No, what variable? What's x? This is in terms of x. Do you agree? Yes. Those are all x values, right? We are now trying to turn it into what values? Into w values. I'm going to teach you the shortest method. You might see something a little different, but this is the shortest method. So here's the thing. Is it still 0 to 2? Yeah. Is it still 0 to 2? No, it's not 0 to 2, because what we're trying to do, everybody, what's the magical thing that happens right now that tells us we're on the right track? What's the magical thing? And it's glitching out for a second here. I'm not sure what's going on here. But what's the magical thing that you can now do? It cancels, right? So I'm really not sure. It's just deciding to glitch out. That's fine. That's fine. Okay, there we go. So the x's cancel, and what are you left with? The integral of e to the w dw. And is that a good sign? Oh, in the 1/2. Thank you. Is that a good sign? Yes. Why? Very specifically. Why are we now in a good place? It's simple. We only have w values, right? So if we only have w values, we can't use 0 to 2 because they are what? X values. What's the thing in the upper right that tells you how to convert between w and x values? W is equal to what? So instead of 0, what do we write? 0, because 0 squared is 0. And then instead of 2, what does it become? So what is the most common mistake I can pretty much guarantee you will make when you're doing these sometimes? You'll keep it as 0 to what? 2. Sometimes they stay the same because what is 0 squared? 0. The whole point of this is the following. You don't actually have to substitute back to x to get an answer on this. It's not asking for in terms of x, it's asking for the numeric value. So watch what happens. We're going to do it slightly differently. Yeah, go ahead. What? Because look, what's the original limits of integration? What are they, David?
2 and 0.
2 and 0, right? But what is w equal?
X squared.
X squared. What's 0 squared?
0.
What's 2 squared?
4.
That's where the 4 comes from. Because originally, what is it? It's 0 to what? Originally, what are the limits of integration?
2.
Exactly.
Then you plug it into the...
Exactly. You convert it. This is really important. You're converting these. Are you with me so far?
Yeah.
This is why this is nice, because what is the integral of e to the w? You know what this is. What is it? What's the integral of e to the w? What is it? What's the integral? If you integrate e to the w, what do you get?
1/3.
No. What is the derivative of e to the w? E to the w. What is the integral of e to the w? E to the w. No, it's okay. Don't apologize. So it goes from what to what? What are you evaluating it from? 0 to what? 4. So what's that going to be? 1/2 times e to the what? Minus e to the... What's e to the 0? So you have 1/2 e to the 4th minus what? 1. So is that a single number?
Yeah.
So did we ever go back to plugging in x?
No.
We did not go back to plugging in x because we didn't have to get the single number. Could we have gone back to plugging in x?
Yeah.
Yes, and if we had plugged x back in, instead of going from 0 to 4, we would have had to done what? 0 to 2. So watch this. So do you see that amount of work right there? You could have plugged x back in and evaluated it from 0 to 2. Do you need to do that?
No.
If you change the limits of integration, you do not need to plug back in the original limits of integration, but you have to change the limits of integration if you don't. So let's do, go ahead.
If you decide to go back to x, do you have to change them?
If you decide to go, so watch, let's do it, let me do it out the other way because you're going to see it probably in the other notes. So watch. So in this case, right here, you see this right here? What was w equal to? Do you remember what w was equal to? W was x squared. So we could have done instead 1/2 e to the what? From what to what?
0 to 2.
0 to 2. Well, what's that going to be? 1/2 e to the 2 squared minus e to the what? Is that the exact same thing? Yeah, it's 1/2 e to the 4th minus e to the 0, which is the same thing. You will get the same answer. The thing is, in this case, the amount of work doesn't really change. It doesn't really change that much, right? But in other cases, substituting back in adds like a lot of algebra. The point is, if you change the limits of integration, if you get one thing out of this class, do not go back to x. Let's do another example, and then let's see if you really get what I'm saying here. So on this one right here, it's relatively straightforward, relatively. What do we want the w substitute? Can we factor something out first, by the way? What can we factor out? What's the easiest thing we could factor out to the front of that integral? It's right there. What can we factor out to the front?
3.
The 3. This is equal to, come on, there you go. 3 times 1 to 3 of what? 1 over what? Okay, so what's our substitution going to be? What's w going to be? 5 minus x. Careful now, what's dw? Careful, what is it? Negative 1 what? Dx. So it's just negative dx. Do you agree with that?
Yes.
So now we do the substitution, but we know that dx is equal to what? Negative dw. So now we do this and we get 3. I'm not writing the limits in. 1 over what? What goes in the denominator? What goes in the denominator? W. But instead of dx, what do we now have? Negative dw. And what do I change the limits to? It's not 1 to 3. What's it going to go from? What's it going to go from? Remember, 4 to what? 4 to 2. Totally legal.
Write it like that, even if...
It doesn't matter if one is bigger than the other. It does not.
Okay.
It does not. But do you understand where the 2 comes from?
Yeah.
Where does the 2 come from? 5 minus 3. Where does the 4 come from? So now, what can I factor out immediately just to make this a little nicer? So I have negative 3 from 4 to 2 of w to the what? There's one more thing that I personally would do to make that a little nicer. What's the one thing about that integral that bugs you a little bit? What's the one thing that bugs you a little bit? It's not wrong, but it might annoy you. What? Maybe, but you know how to integrate that, right? Do you see the 4? What's annoying about the 4 and the 2? You generally like the smaller one to be on the bottom, right? So could you switch them?
Yeah.
What happens if you switch them? Yes, something does happen. What happens when you switch the limits of integration? You know this. It flips it. It makes the whole thing the opposite sign. So if it was negative to begin with, what does it change to? Oh, look. Is that just a little bit nicer? Where you can, I like getting rid of negatives because sometimes they mess you up. So now, what is the integral? What is the antiderivative of w to the negative 1? 3 times what? What's the integral of w to the negative 1? ln of... Right. And we're going from what to what? 2 to what? 4. So what's the answer to this? 3 times what? ln 4 minus ln 2. And actually, can you simplify that a little bit? I would love you to stop right there, but you can simplify that. Subtraction with logs, what do? Do you remember? Addition, I'll remind you, addition was multiplication. Subtraction is division. So what is this? 3 times ln of 4 over, which is just 3 ln what? It's important because if I were to give you like a multiple choice or you saw an answer key, that would be the nice answer. Now, could you substitute back in for x? You could, but this is shorter. Let's do one more. Let's do one more and see how it goes. So the key is, remember to change the limits of integration. Remember to change the limits of integration. So let's do a trig one right now. Don't say it out loud, but think in your head, what do you think we should do first on this one? Think in your head. Don't say it out loud. I want you to think about what you think.